Thank you. So next, I'd like to introduce Abraitis. He works for NetDev Open Source Routing with me, and he's one of the maintainers on FRR, and he wants to talk a bit about what happened over the last 5 years with FRR and where we're standing right now. Go ahead.
Hi, everyone. My name is Donatas. Today, I'm going to talk about where we are with our beloved suite FRR, which is already 5 years since the fork has been created, as Martin mentioned before. At the moment, I'm one of the FRR maintainers and working at NetDev as software engineer and SRE as hostinger. FRR uses semantic versioning, and releases are pulled every 4-month cycle in most cases. Release dates are known in advance, and it eases development branch by splitting into separate parts, like freezing the development branch where no new features can be merged. 2 weeks later, we pull stabilization branch and new features can go in. 2 weeks later, again, we tag stabilization branch with additional RC tag and running additional per-release compliance test to make sure we don't have any regressions. Two or more people from maintainers are assigned to be release managers and rotate to get more people familiar with the flow and to avoid kind of struggling with coming releases. Since we don't have LCS releases, we are trying to backport critical bug fixes or misbehaving features to the 1 or 2 latest versions. Also, we use Mergify, I don't know how to pronounce it correctly. So, and it kind of helps to deal with backports. Some details about our CI system. The first phase is CI builds the source on all the supported OS distributions, builds the packages, deps, RPMs, snaps, whatever. The heavy lifting part is topology test. Takes the most time. And the last part is kind of running Slang analyzer, address sanitizer, just to check if we don't have any new memory leaks, buffer overflow, etc., similar to Valgrind. The average build time is around 2 hours, and unfortunately, 50% of the builds fail, but mostly due to various other external conditions like OS upgrades, repository failures, network failures. Some topology tests fail mostly due to timing issues and to be fixed somehow. Forgot to mention that we use our FRR bot, which is kind of our front line to make sanity pre-flight checks for commits. It's not working. Oh, this is just a big picture of the latest important changes since 7.2 release. As an example, lots of missing features and RFCs were implemented in BGP, like extended message support, enhanced route refresh, long-lived graceful restart, EVPN multi-homing, open delay timer, lots of them. So I can cover all of them in this short talk. So I just grabbed a couple of less known or even unknown changes and gonna talk about them shortly. Yeah, it's time to show how to configure BGP. I'm joking. As mentioned before, I just took 5 less known changes and gonna talk about in short. First, Lua hooks. Hooks allow you to do some actions in time when the event happens. And in FRR, Lua is still in the early stage, but with more efforts, this would be very promising in the future. At the moment, we have a single hook for Zebra, but we have more for BGP and route maps, which is kind of useful. At the moment, FRR requires Lua 5.3 because all the existing C Lua bindings are based on 5.3. Let's say you have a client's database with IP prefixes, and you want to put some extra data to the logs before they are parsed and sent to the aggregation or any storage like Kafka, Elasticsearch, etc. So it can be helpful here. Also, we can specify a Lua script that's going to be called on every route update from a particular peer. In this example, we set med attribute to 333 for every newly received routes. And at the moment, we can override only med and local preference attributes by Lua. But it's very easy to extend, and decoders and encoders should be extended as well. Technically, we can even implement our kind of local aware validator for the prefixes or so. Another one interesting and handy daemon FRR has is shard-D. It's something like a testing framework to generate millions of routes and do the performance testing. You just specify the first address, the next hop, and the routes to be installed, the number of routes to be installed. Redistribution works the same way as with any other protocols. It has an administrative distance of 150. Shard-D can send also opaque data, and you can show that information in CLI with the routes, as in this snippet. One real-life example, let's say, when I was implementing BGP extended message support, and I needed tens of thousands of prefixes to be bundled for the same BGP update message to be above 4K bytes. So it helped me to send and verify. Or let's say you want to verify how the files, the routes are processed, how many resources do I need, or how does my router behave with millions of routes. What is tracing at first? Tracing is an advanced performance and analysis tool. but it's not just about the system tracing like sysdig strace or TCP dump. It's kind of more low level and can be used to track down specific events, specific functions, instead of just syscalls. I'm going to talk about two tools, LTTNG and SystemTap. LTTNG stands for Linux Trace Toolkit Next Generation. FRR has tracing support since 8.0. And by the way, has anyone used tracing in FRR? Okay, got it. So in order to use LTTNG, you have to compile FRR with LTTNG flag. And basically that's it. And below is an example of how to use it. Before eBPF, SystemTap, I guess, was the most powerful tracer. It can do much more, like user space probing or kernel hacking. I've seen people even patching kernels live. It's called Guru mode in SystemTap. As with LTTNG, in order to use it, you have to compile with USDT flag. And keep in mind that you can compile FRR with both support, I mean LTTNG and USDT. Choose one. As an example, BGP at the moment has around 30 trace points, but SystemTap allows you to hook on whatever you want in the code on a specific function or on a specific line even. And it differs from LTTNG that you compile the script, like on the right side, into the kernel module, and you just load it and run. But it comes with some safety tricks. You can crash or freeze the application, sometimes the kernel. The video should show up, I don't know. Never mind. Long-lived graceful restart is a graceful restart extension for BGP, and it allows you to retain stale routes longer than 1 hour, which is an actual limitation in a standard graceful restart. When graceful restart timer expires, stale routes get a well-known LOGR stale community. Routes are recalculated to make sure they are less preferred. And routes that have a well-known no LOGR community are flushed immediately, and others are kept for longer time as configured. We can even disable our standard graceful restart by setting restart time to 0, and that means it's totally skipped and long-lived graceful restart is activated instead. We have it since 8.2, if I remember correctly. As an example, BGP can send multiple identical announcements with an empty community attributes if stripped at egress. And it's absolutely undesired behavior, and why do we need to send an update if it's not an actual change at egress? As an example, X1 receives 2 paths with communities 2 and 3 that are tagged appropriately Y2 and Y3. In order to induce an update for prefix P, we just disable the link for Y1 and Y2 and wait for our days at C1. When X1 sends an update to C1, it strips all the communities, and we don't need to send an update message to C1 because the attribute's actually the same. So it's enabled by default in FRR since 8.0 release, and graceful restart, route refresh are exceptions, and updates are forced to be sent. Okay. 4 years ago at Hostinger, we missed a feature in Cumulus Linux to set a metric or community for a default originate command. And then I started looking at the code and discovered that it's not implemented, and it might be fun to do this. But before that, at that time, I didn't have any experience in coding or even with C language. But I was still motivated to go ahead and learn new stuff, at least how protocols work from the developer perspective. And I want to ask you, do we have any contributors here to FRR? Not much. How many of you use FRR? Okay. So I'll provide a quick overview how you should start contributing. The first step is just creating your own fork of FRR repository. Create a separate branch, do the changes, apply code formatting, because otherwise you have to fix it anyway. Do some local unit test. I mean, not do, but run. They are already, and commit the changes. And by the way, every new CLI change, or even a new protocol, daemon, whatever, requires documentation, topology test. It's kind of useful to have in advance. And yeah, then just create a pull request in GitHub based on the development branch, and in a couple of seconds, a few tests start. As mentioned before, 50% of the builds fail, but fortunately, we can rerun them by triggering on GitHub by just writing a comment like CI rerun, and the reason for that, when it's green, it's a good sign to start reviewing. Do expect that some PRs can be hanging for longer time because some changes require more attention, discussions, or so. Pull requests marked as draft are skipped from reviewing. We have, every Tuesday, we have a technical community call. You can join it as well to discuss recent PRs and issues a bit. I suggest joining our FRRouting Slack. Mailing list also exists, but they are kind of abandoned. Okay, the most interesting part. overall, we have around 23,000 of commits and around 7,000 pull requests merged. Kind of steady growth. This is the graph to show how many commits on pull requests we have per release. As we've seen before in the timeline, 8.0 was the huge release, and but usually 1,000 commits and 500 pull requests per release is a normal pace. The merge close pull request ratio is quite good when dealing with large amount of pull requests. Closed in some cases can be a real fix, but it can be a duplicate or the author is requested for more changes, etc. Oh, time is over. I have to speed up. Created closed issues ratio is kind of the same, except for the last year. We closed more issues than was created. Real profit. This is the unique number of contributors per release. Again, 8.0, a poll. NVIDIA and the devs remain the winners, competing in the battle when talking about the number of commits per organization. And yeah, thanks. I think I can answer a couple of questions if the time is okay. And by the way, we have Martin, 2 Davids, and they know much more than me, so you can ask what you like about the FRR or.
So yeah, any quick questions? Okay, see over there.
It's Maria here, CZNIC. I'd like to ask a performance question. If you are implementing Lua bindings, have you measured how long does it take? We were trying to do it in BERT and it totally failed on initialization of the Lua context.
Personally, I didn't. So maybe David can know. So.
Okay, thank you.
Basically, Lua was implemented as a GSOC project. So, but I don't know about any performance testings.
Okay, thank you, Donatas.